Okay, so this is going to be our Unit 1, Day 8 lesson video here. And in it, we're going to discuss piecewise functions and domain and range. We already know what domain and range is, but of course, we're going to review and kind of advance upon the foundation that's been laid before us. So, first of all, let's talk about what is a piecewise defined function, right? So, a piecewise defined function, that's a terrible arrow, is simply a function that behaves differently at different parts of our domain. Okay, so for example, uh, we've got an example of a piecewise defined function here. So what we see is f of x, right, is behaving this way whenever x is less than negative 2. So here is negative 2, and it's behaving that way. It's behaving like negative x plus 2 until we get to this point right here at x is negative 2, right? And it behaves that way everywhere less than negative 2. Okay, then whenever x is 2 or greater, or negative 2 or greater, right, it behaves like a parabola, namely y equals x squared. And that's where we see this right here in blue. It begins to behave like a parabola everywhere at negative 2 and past that, right? Okay, so that's all a piecewise defined function is. So, real quick, let's talk about what a step function is. So, a step function is simply a special kind of piecewise function, right? And you can tell by this picture, I mean, it kind of resembles steps. Okay, so here's the actual piecewise defined function. First, it simply behaves as y equals negative 2, right? And it behaves that way until we get to negative 3 here, right? It behaves that way everywhere to the left of negative 3, all the way up to that point, but not exactly at negative 3. So we would use an open circle like that because we've got a less than symbol. Okay, then it behaves this way. It behaves like y equals 1, right? From negative 3 and to the right of that until we get here to positive 2. And again, we would have open dots on both ends because, and actually, I'm lying to you, we wouldn't have an open dot here on the left at negative 3 because we are including, right? That is less than or equal to. So we would include x equals negative 3 here in this case, but we would not include uh, positive 2 here because we're saying it's less than 2 when it behaves this way, right? So it behaves that way till we get to precisely 2. Then, once we get to 2, it starts behaving like this, y equals 3. Okay, so that would be an open circle there, and then it behaves that way continuously on to positive infinity. Okay, so again, that's a step function. It's just a special kind of piecewise. Then we're just going to see some more examples and also talk about how to define domain and range. So this is an absolute value function, which is very much a piecewise defined function, right? It behaves one way until we get here to x is negative 1. It behaves that way on the left, right? With a negative slope coming down, decreasing. Then once we get to negative 1, it starts behaving totally differently, all the way onto positive infinity. Okay, so an absolute value function pretty much just is a piecewise defined function with respect to the Cartesian plane, at least when we're talking about geometry. Anyway, going off topic, let's talk about domain and range. Okay, so if you remember, domain is relative. Domain is relative to x, right? And it just means the possible x values here, right? That's all it's going to mean there. Okay, so when we talk about range, however, right, when we talk about range, well, we're relative to y. And of course, we mean the possible uh, y values. Okay, so let's talk about that given this example here. So let's talk about domain and range of this particular function, namely f of x equals the absolute value of half x plus 1, right? So its domain, I mean, these arrows in either direction tell me that x can be anything that's a real number. So x can be all real numbers. And the way that we would say that, the simplest way we could say it, is using an inequality. So we could say negative infinity is less than x is less than positive infinity. And you're probably wondering, well, why wouldn't we say less than or equal to? Well, can you really include or be equal to something that is infinite, infinite? No, you can't. So we wouldn't include it. A shorthand for this notation that I just used is called parenthetical or interval notation. So this is inequality notation. This is inequality notation. And besides that, we also have parenthetical, aka interval notation. So anytime you hear either one of those, what we mean is the shorthand for this inequality notation. That shorthand would simply look like this. So if my domain is from negative to positive infinity, well, that's all I really care about is my endpoints, just like this here. Okay, so this means precisely the same thing as this, right? It's a shorthand of saying it. Okay, and then in what we call set notation, right? And set notation to me is just, I don't really like it, and you're not going to see it very often. You're going to see parenthetical notation a whole lot more just because of how convenient it is. You'll also see some inequality notation just depending on the context of what it's being used in. But anyway, I digress. We still need to know about set notation. It's kind of useful. So set notation, we would say it real fancy. So I used a curly bracket here. So open curly bracket, and I say for domain, since it's domain, I say x, then bar. This bar is a short way of saying x such that. Okay, so x such that um, x is an element of R. Okay, so that's the Greek letter epsilon. That just means element of, right? And then this fancy looking letter here, this fancy looking script R, is just the symbol for real numbers. Okay, and we'll get into set notation a whole lot more in the next lesson. I'm not going to focus on it too much today in this one, but just a little bit of a taste of things to come. Okay, so now let's talk about range. We talked about domain, now let's talk about range. So, what would my range be? Right? So, range is relative to dimension y. So, let me back up. Let me back up. For those of you that have a geometry kind of brain like I do, okay, so domain is dimension x. So we're dealing only in dimension x. So where do we start on the left? Where do we end on the right? Which is why we say negative or positive infinity, left or right, respectively, right? We start uh, infinitely to the left and infinitely to the right is where we end, right? With range, it's the same idea as domain, exact same idea, except we're talking about vertical dimension y, right? And we think of it accordingly. We say, where do we begin at the bottom and where do we end? Where do we end at the end, at the top? I mean, okay, so we begin here at the bottom, right, at y equals 0. Okay, so that's precisely what we would say. We would say 0. And we know that we actually do touch at 0 because if I plug in a 0 here for x, right, 1/2 times 0 plus 1, right? Well, that would give me, what do you call it? That would give me 1. I guess that was the wrong example to use. I would have to use -2. Porque I am stupid. Okay, so when I use -2, right? I got thrown off with my scale here. That should have been a -2 this whole time. Whoopsie. Anyway, so when x is -2, that's when we're 0. Well, why is that? -1/2 times -2 is -1 plus 1 equals 0, right? So we actually do touch right here. Okay, so what we would say is 0 is less than or equal to, and I'm going to use the letter F, right, instead of Y, just being a little fancier, uh, which is less than positive infinity, because really we're going to continue going up on either side of the graph here. We're never going to stop increasing upwards, right? So we end up at the top infinitely. Okay, so then on to parenthetical notation. Well, I wouldn't use a curve bracket this time, right? I would use what's called a square bracket. Okay, so I would use a square bracket, 0. That means that I'm including this endpoint. Okay, so I'd say 0 onto my upward end, my upward bound, right? And of course, I would use a curve bracket for infinity because I can't include that. Okay, so let's look at another one. Get this really into perspective. So now we've got a piecewise function. G of x behaves as -x plus 2 so long as x is less than -2. Then whenever x is greater than or equal to -2, it behaves a different way, right? So domain here, well, again, we see we just continue infinitely to the right, infinitely also here to the left, right? So my domain, if we're talking about inequality notation, is just all real numbers again. So negative infinity is less than x is less than positive infinity. Or even simpler in parenthetical notation, negative infinity to positive infinity. Set notation would be x such that x is all real numbers. And then got to use my little fancy curly brackets. Another way to say this also, we wouldn't have to say x. I mean, we would have to say x is on R, but another thing we could simply do is use this and plug it into our set notation. We could just say negative infinity less than x less than infinity, right? So now what we're fully saying is we have an x such that x is a real number from negative infinity until we get to positive infinity. Okay, range. Well, we see we've got a bottom, quote unquote, right? Here at y equals 0, we'll say. So we start at the bottom at 0, and we actually do touch here, right? So when x is 0, so this is the y-axis, so that's at x equals 0, right? When x is 0, okay, if I plug in a 0, if I plug in a 0 right here, I don't know why I drew the arrow not right there, right? I would just be at 0. So that means we include this endpoint, so I've got to use less than or equal to. Okay, so 0 is less than or equal to the name of my function, right? G, that's like our y. And we see that we just continue upwards, right, on either side up to positive infinity. So that would be my upward bound. So I'm just going to say 0 is less than or equal to G is less than infinity, or in parenthetical notation, I would use a square bracket, meaning I include my lower bound, right? My upper bound, well, I can't include infinity, so I use a curve bracket. And then set notation, we would say G such that G is greater than or equal to 0. And that would be as far as I need to take the set notation. Okay? Or you could literally just take this and plug this in here instead of what I did. Either way, that would be acceptable. Okay, last example. And this one is particularly important because it's kind of exceptional compared to the previous one. So h of x equals all of this nonsense here. Okay, so it behaves just like y equals x, whenever x is less than or equal to negative 1, right? Then it behaves like uh, y equals 2x, right? Whenever x is larger than negative 1, but less than 3. And then we see that changes behavior again whenever x is larger than 3. Okay, so what does that mean for our domain and range, right? So I'll just use green. So obviously, when we're talking domain, starting on the left, our left bound is negative infinity, right? So we would say negative infinity is less than x, and we would continue until we got here to negative 1, right? But we see that 1 is still included in our domain. Even though it's not included there, it's included right here. That's why we have a filled dot right there. Okay, so we would say less than or equal to, um, well, not or equal to, let's just say it's continuous, right? Then it's continuous until, so it's filled in here at x equals negative 1, right? Then it continues until we get here to positive 3. Well, then we see, right, we aren't filled in here, right? Because we're saying x is less than 3. Okay, cool. Well, what about over here? Well, now we're saying x is greater than 3. Okay, so that means that 3 just does not happen in our domain. Okay, so the way that we would say that inequality wise, so we're going to say negative infinity is less than x. We're continuous all the way until we get here to 3. So I'm just going to say, we're continuous until we get to 3. But obviously, we still continue after 3, right? It's only 3 that we don't skip. We would just say, x does not equal 3, but that's not, correct notation to use, right? And I'll show you something with the set notation that we can say here in a second. But as far as this is concerned, so we would say negative infinity until we get to 3, or from 3, right, we continue until we get to positive infinity. Notice neither time did I include 3, right? And we see that it's not included here nor here in our domain. Okay, so I have to say it that way. So that's how I would write it out for my domain as far as inequality notation. Now, parenthetical notation is just going to look like this, right? Okay, and what are we going to say for or? Well, you'll learn, especially if you're a computer science person, uh, a lot more about Boolean logic. But what we'll use for the word or is union. Check. So it just kind of looks like a U, a weird U like that. Okay, that just means or, and we just continue 3 to positive infinity for our right bound. Okay, so again, we've excluded 3 both times, just like we did here. Okay, so let's put that all into perspective with our set notation. So set notation would be our domain is an x such that, well, the simplest thing to do here is to say that x is an element of R. It's a real number, right? But x does not equal 3. That would be the simplest way than to just take all this crap here and plug that in. You could still do that. That's just a lot more to write. It'd be simpler to just say x is a real number, x does not equal 3. Okay? Then range. Okay, so this is where it can get tricky. So let me erase some of the nonsense that I have on here. Okay, so we're still going to need all these key numbers, right? So let's talk range. So obviously, we begin either way we look at it at the bottom, right? Infinitely at the bottom. So we're going to begin, our lower bound would be negative infinity is less than h, right? And we continue and continue until we get from negative infinity here to negative 3, we can see, right? Then at negative 3, well, we notice even though it's not included here, it is included here, right? But then something happens here, right? So we see we've got some weird holes to account for in our range. Those holes in our range directly correspond to the fact that we're saying x does not equal 3. So we need to see how does this guy behave at x equals 3, and we must exclude that. Because we excluded 3 from our domain, we must exclude it also from the range somehow. The only way to figure that out is to plug in for 3 on this equation and on this equation. Okay, so right here, 2 times 3, well, that gives me 6. So that means h quite literally cannot be equal to 6, right? And we look and we see, well, duh, this is h equals or y equals 6, right? And h cannot equal 6. We've got an open circle there. We're not touching at y equals 6, right? Okay, then here we also see that if I plug in a 3 here, right? -3, right? So h can also not be -3. Well, let's look and see. So here at -3, again, we see we do not account for it here, right? At all. We're not accounting for y equals -3, but we are accounting for everything just after y equals -3, all the way until we get here, but then we're also accounting for it here. So this is really our only other hole in our range, okay? So we would say our range starts from -infinity and continues until we get to -3. We cannot include -3, right? For the same reason that we just pointed out here a second ago. And then we're going to have to use an or statement like we did previously in our domain. Or we would say we go from -3 until we get to 6, right? And then that's where we stop, right? We don't go on to -infinity because we literally stop right there. Okay, so then parenthetical notation. That's just a simple little translation to make here. So lower bound is -infinity, upper bound is -3. Union, -3 to 6. And curve brackets all the way around. We're not including -3 at all, right? And we're also not including +6. Okay, well, what about set notation? Well, that's where this right here is going to come in handy. So for set notation, we would express our range as h such that h is an element of R, it's a real number, but we would also go on to say that h does not equal -3 nor 6. And we're done. Okay, so that's all for this video. Like always, if you have any trouble or need anything, send me an email or just come see me during tutoring or during class. Goodbye.